Okay, this is the final lesson in Unit 3. It's called Solving Quadratic Equations with the Quadratic Formula. We've already solved quadratic equations by factoring, using square roots, and by completing the square. But those don't work every single time. Sometimes you can use them, sometimes you can't. The quadratic formula is going to work every single time for any quadratic equation. That's the good thing. The bad thing is it kind of takes a while. It's not the quickest way. So here's the formula right here. Now, the first thing you need to do is you need to make sure these equations are equal to 0. So for this problem right here, I'm going to bring the 2 over, so it's equal to 0. So I get 3x squared minus 5x minus 2 equals 0. Then you're going to identify what a, b, and c are. A is the number before the x squared term. So in this case, a equals 3. B is the number before the x term. In this case, b equals negative 5. And c is the number all by itself. In this case, c equals negative 2. So now what you're going to do is you're going to substitute into the formula and then simplify and solve. So this symbol means opposite of b. So b is negative 5. Take the opposite of that and make it positive 5. So again, that symbol up front does not mean negative. It means the opposite sign of whatever b is. Plus or minus the square root of b squared, so negative 5 squared, minus 4 times a, which is 3, times c, which is negative 2. So I recommend identifying a, b, and c first. And that's divided by 2 times a, 2 times 3. Now let's simplify. X equals 5 plus or minus. The denominator is going to be 6. That's easy. Under the square root, negative 5 squared means negative 5 times negative 5, so that's going to be 25. Negative 4 times 3 times negative 2 gives you plus 24. One step at a time, make that 49 under the square root. Divide by 6. You can make the square root of 49 7, so x equals 5 plus or minus 7. And now we can do our 2 equations like we've done in the past. We can do x equals 5 plus 7 divided by 6, and x equals 5 minus 7 divided by 6. So the first one gives you 12 divided by 6, x equals 2. And the second one gives you negative 2 divided by 6. I'll simplify that to x equals negative 1/3. Okay, next page. Example 2 is already equal to 0. That's good. That's what you want. So let's identify a, b, and c. In this case, a equals 1, b equals negative 8, and c equals 10. So I'm not going to copy down the formula. You can look back at that in the first page if you want, or you can write it down yourself on a separate piece of paper as you're watching the video. X equals opposite of b. Opposite of negative 8 is positive 8. Plus or minus the square root of b squared, so negative 8 squared, minus 4 times a, which is 1, times c, which is 10. It's all divided by 2 times a, which is 2 times 1. Okay, so x equals 8 plus or minus. I'll make that a 2 in the denominator, just get rid of that. Negative 8 squared is 64. 4 times 1 times 10 is going to be minus 40. One step at a time, let's make that 24 under the square root. So x equals 8 plus or minus the square root of 24 divided by 2. Simplify the square root of 24 using the perfect square number list, 1, 4, 9, 16, 25. In the first example was a perfect square. This one is not. But you can simplify that to square root of 4 times square root of 6. and that's divided by 2. Simplify the square root of 4. Finish that up here into 2. And now, if this number with the star, and that number with the star, and that number with the star, if those three numbers all have a common factor, you're going to divide by that common factor. So they all have a common factor of 2 in this example, so we're going to divide each one by 2. So we get x equals 4 plus or minus 1 square root of 6, which I'm just going to put square root of 6. 2 divided by 2 is 1. You don't have to write divided by 1, so I'll write this as my final answer, and that's the end of that one. If I don't sound like I'm in the best mood, it's because I just recorded this video and it did not save. I'm not sure why it did not save. Something wrong with the computer, I guess, and this internet connection at the school, but I just made this entire video, did not save, so I'm redoing it. I'm going a little faster than the first time though. But yeah, so in example 3, solve that by using the quadratic formula. It's already equal to 0, so I'm going to say A equals 4, B equals 3, and C equals 2. When we substitute into the quadratic formula, we get the following. X equals opposite of B, meaning negative 3, plus or minus the square root of B squared, so 3 squared, minus 4 times A, which is 4, times C, which is 2. All divided by 2 times A, in this case, 2 times 4. Let's simplify that. X equals negative 3. The denominator is just 2 times 4 is 8. And the numerator will be 3 squared is 9. 4 times 2 is actually 9 minus 32. So this is new because you did this in Algebra 1, but you did not do square roots of negatives. Now we have square roots of negatives. At least we do in this case. So 9 minus 32 is going to be negative 23 under the square root. So x equals negative 3 plus or minus square root of negative 23 divided by 8. And now what you're going to do is you're going to take out the square root of negative 1, and you're going to write that as I. So x equals negative 3 plus or minus I square root of 23, all divided by 8. And you cannot simplify the square root of 23 anymore. So that's the answer. Okay, this next example, get it equal to 0. So I like to keep the x squared term positive. So I'll bring the 6x over, and I'll bring the negative 7 over. So I'll get 2x squared plus 6x plus 7 equals 0. Okay? What if you bring the 2x squared over that way, and you get negative 2x squared minus 6x minus 7? Well, you'll have the same final answer in the end. Okay? But for me, I have A equals 2, I have B equals 6, and I'll have C equals 7. So quadratic formula time. X equals opposite of B, so negative 6, plus or minus the square root of B squared, so 6 squared, minus 4 times A, which is 2, times C, which is 7, all divided by 2 times A, which is 2 times 2. So x equals negative 6. Let's make that 4 in the denominator. Just get rid of that. 6 squared is 36. Minus 4 times 2 is 8. 8 times 7 is minus 56. That's going to give me negative 20 under the square root. I am going to simplify negative 20 using the perfect square number list. And I'm going to rewrite it as negative 6 plus or minus square root of 4 times square root of 5 times square root of negative 1, all divided by 4. Square root of 4 becomes 2. Square root of -1 becomes I, and the square root of 5 stays. And again, we have these three numbers. They have a common factor. So we're going to divide by that common factor of 2 to get the final answer. X equals -3 plus or minus I square root of 5 divided by 2. Okay. So the part under the square root, the b squared minus 4ac part, that has a name that's called the discriminant. If the discriminant is greater than 0, meaning if it's positive, that means the graph crosses the x-intercept twice, and it means that we have two distinct real solutions. Distinct means different. So I'm just going to refer to that going forward as two real solutions. If the discriminant b squared minus 4ac equals 0, that means we have one solution because it crosses the x-axis once. I'm going to refer to that as just one real solution. The reason why it's one is because when you add or subtract the square root of 0, it's the same each way. There's only one solution. And if the discriminant is less than 0, meaning if it's negative, it means the graph never crosses the x-axis. It means we have two distinct non-real complex solutions. I'm going to refer to that going forward as two imaginary solutions. Okay, so last page. Describe the type and number of solutions. The first thing is first, you have to have this equation equal to 0, and it is. And let's identify A, B, and C. A equals 1, B equals 6, C equals 8. Make sure it's in standard form, okay? So make sure it goes x squared, then x, then your constant all by itself. And now we're going to evaluate the discriminant, b squared minus 4ac, and let's see what we get. So b squared is 6 squared minus 4 times a, which is 1, times c, which is 8. So it gives us 36 minus 32, which equals 4. If I said evaluate the discriminant, your answer would be 4. But describe the number and type of solutions. Since 4 is positive, that means we have two real solutions. As long as this number is positive, it means we have two real solutions. Example 6, it's not equal to 0, so we have to make it equal 0. Add 9 to each side, x squared plus 6x plus 9 equals 0. So A equals 1, B equals 6, C equals 9. Let's evaluate the discriminant, b squared minus 4ac. 6 squared minus 4 times a, which is 1, times c, which is 9. So we have 36 minus 36, and that equals 0. So since this discriminant is 0, it means we have one real solution. Okay. And this last one, I'm sure you can guess the answer ahead of time because there's 3 types, 3 possibilities, and we have 3 examples in the notes. Okay? A equals 6, B equals -2, and C equals 5. Let's evaluate the discriminant of b squared minus 4ac. So -2 squared minus 4 times a, which is 6, times c, which is 5. So it gives us 4 minus 120. So -116. So that is negative. And since that answer is negative, it means we have two imaginary solutions. And that is the end of that lesson. That lesson was called Solving Quadratic Equations by completing this. That was called Solving Quadratic Equations by using the quadratic formula. And that's the end of the entire unit. Okay, so that's the end of Unit 3. Unit 3 was on solving quadratic equations, so that was the unit title. We're done with this unit, and we're done with this lesson.